Industrial vibrators are commonly used as flow aids in bulk material handling and processing environments. They are simply designed to impart vibration energy through the vessel wall to activate stagnant bulk material and induce material flow. Shaking a salt shaker or hitting a bucket of material to start flow is the same concept. In fact, the simplest vibration tool still widely used is a dead blow hammer. Vibrators are pneumatically or electrically powered and come in various sizes with specific designs to create high or low frequency vibrations depending upon the application. Functionally, they all do the same thing: impart energy through the vessel surfaces to help activate material and induce flow. While it may seem more cost-effective to install a single vibrator versus a typical AirSweep system with multiple components, the advantage of the AirSweep system quickly outweighs the initial cost and provides a fast return on investment. The utilities cost of a constantly running vibrator far outpaces the cost of the intermittent pulsing of the AirSweep system, allowing the AirSweep system to quickly recapture the initial implementation costs. The AirSweep system also outperforms the vibrator on wet, sticky, and stringy products, resulting in increased process productivity. Vibration de-aerates and compacts material, which can create rather than solve flow problems. You can easily see the sand pack in this tube when vibration is applied. In contrast, the AirSweep Pulse activates and fluidizes even wet and dense material. Vibrators will fatigue and crack vessel walls and structures, resulting in costly downtime, repair, and replacement. The pulse of the AirSweep, however, induces no vibration whatsoever to the vessel or structure, while providing its powerful sweeping action to get stagnated material off the walls and flowing. Vibrators create noisy work environments that can be detrimental to health and safety. The powerful pulse generated by the AirSweep system is not only quieter, it's much more effective. Quiet operation, fast return on investment, non-destructive to vessels, and powerful material activation and aeration. All good reasons to choose AirSweep for on-demand bulk material flow. Now we'll compare the AirSweep and Vibrator's ability to induce flow of damp sand from this small hopper. The sand has a bulk density of approximately 70 pounds per cubic foot, is moist to the touch, and will agglomerate slightly when squeezed together. We've loaded 1 cubic foot of material into the hopper. The discharge size is 4 inches in diameter. When the discharge is opened, no material starts to flow, so it's clear a flow aid of some kind is needed. First up is the dead blow hammer, which doesn't produce flow. Now the vibrator is started up. One vibrator mounted as shown is a typical configuration for a vessel of this size, but it also is not producing any steady, significant flow from the hopper. From the view inside, it's easy to see the de-aerating effect of the vibrator, as the sand becomes more compact and doesn't exit the vessel at any significant flow rate. An inspection of the outlet reveals that it's tightly plugged with compacted material. The hopper is equipped with 4 small air sweeps positioned 90 degrees apart from one another at elevations of 6, 8, and 14 inches above the outlet. This is a typical air sweep configuration for most vessels and materials. The air sweeps will be pulsed one at a time in a sequence, starting with the lowest unit and ending at the highest. Each pulse is 1/4 second. After 12 AirSweep pulses, the hopper is empty. The total elapsed time to empty the hopper was under 30 seconds. AirSweep versus vibrators? It's really no contest.